I wanted to fit these carbs to my Mini. And to do that, I 3D scanned the engine bay, the carbs, modelled it all up, and then 3D printed the right induction manifold so it all fit beautifully. Now, if you're interested in that, you're in the right place, because I'm going to show you every single step of how I got there. Welcome to Making for Motorsport, where we make more, spend less and go faster. So way back in 2020, I wanted to fit individual throttle bodies to the Mini. So I made this video and 3D printed these manifolds, and it worked well. And to do this, I used the computer, yes, but I also used a different type of CAD, cardboard aided design. Alongside a few guessed measurements and a bit of trial and error, it all worked out well. And I've come full circle because now I want to put bike carbs back on the Mini because it's just easier. But now it's 2024 and we've got consumer grade 3D scanners that are actually useful. That should make life a lot easier. So I'm going to take you through my exact workflow that's took me from here to here. Let's dive in. The first step in this process was getting the scans in the first place, and I started this video about 6 months ago, so what you see here is generic scanning footage that isn't me scanning the actual items themselves, which is of course the carbs and the engine bay. Seeing as this video isn't actually about 3D scanning, it's about using the output meshes from 3D scanning, I don't think this matters. You can use any 3D scanner you wish to generate the meshes to design from. And if you are interested in 3D scanners, I recommend you check out some of the review videos I have on the channel. Regardless of your choice of scanner, what you end up with is the same, a mesh. And we have two that are going to be perfectly useful for us. So most 3D scanning programs will kick out the mesh in a weird orientation in the global coordinate system. So the first job is to reorientate this within the 3D space so it makes a bit more sense to us. And there are many ways of doing this. I've got videos on doing a 3-2-1 alignment in GOM Inspect, and I've also done a video showing how to do this in Fusion. But one of the easiest ways I know how to do it, especially when there's no flat surfaces or planes that allow you to do it in a more scientific way, is in Mesh Mixer. So what is Mesh Mixer? Well, it is an old program that is largely obsolete, as all of its functions have been kind of absorbed into programs that are now being supported, and this is not being developed anymore. But it's fine, because what that means is that this is a highly focused program to allow us to deal with meshes only without being weighed down with all the other stuff like you get in Fusion. So we can import the mesh that we're interested in, and you can see it appears in a weird orientation compared to the 3D space that we're looking at, which is represented by the box down here. Next job to do is to click Edit and then Transform on the menus on the left, and then click the W to select the world frame coordinate space. So we can use the rotation tools within the planes between the axes and also the arrows along the axes to rotate and move the mesh around the 3D space until it better fits with the origin and the way that we normally think about the coordinate system. So once we've done the engine bay, then make sure to save it. And by save it, don't save the project file, export it as a new STL. And that will give you a new STL which is aligned to that global coordinate system. So if you import that to something else, it will be in that orientation. So now we've got the engine bay in position, we can actually import the manifold into the same workspace within Mesh Mixer. And we can use the same transform tools to orientate the carb within the engine bay to an area which we think is about right. Now we can tweak this later, that's not an issue, but it gets us really quite close in a very simple and easy way. So now we're going to jump in and do some modelling. So my program of choice is Autodesk Fusion. Why? Because it's the one I'm most familiar with. I highly recommend it. There is a free version still. There's some restrictions on it, but nothing that really stops you actually using it or affects any of this functionality. I will show you where it is here. There'll be a link in the description, but you basically need to scroll all the way down to the bottom of the page to find the right link. They make you work for it, but hey, it's free software, so come on. Anyway, let's dive straight in. first off we go to the mesh ribbon, and then we use the insert mesh command. And I do that because it's a little bit tighter. You get better options than if you just open it. So make sure you use the insert mesh command. Select computer, and first off we'll do the engine bay align scan. So we bring that in. Over here you can see there's the insert mesh window. So at the moment it's imported in a different orientation than we saved it. That's because Mesh Mixer uses Z as up and down, whereas Fusion uses Y as up and down. So what you can do is you can use this flip up direction command to change Y and Z, and you can see there we have it. It's looking pretty good. Don't use either of the center or the move to ground commands, because that will change your XYZ positioning relative to the other item we're going to import. Bring it in, and that looks pretty good. We've got all the information we need. Right, let's import the carbs. So we do exactly the same process over again for the carb file, and if we use flip up direction before, then we need to do it again, and they should line up just as they were in Mesh Mixer. The first thing we want to do is really to actually properly interrogate this and see if there are any clashes. Like for example, we can see this clash here, but that I know is a breather hose, so that will move. There's a few other things around the place, but I know, such as down here, I know again that's a hose, so we don't have a problem there. But we want to look at this properly. So what we want to do is to use sectional analysis to go through and take slices and see if there is any clashes. To go to inspect, we use the section analysis, and we can use an origin plane if we want to. So we're going to use XY, and we grab the arrow and we can rock it backwards and forwards, and we can have a look. Lots of clearance with the bulkhead this end, so let's have a look at the other end. Okay, is there an issue here? Again, that looks pretty close, but I know this is a battery lead. Ideally, you'd clear all these things out of the engine bay before you make a scan, but I didn't have time, but it's not a problem. So I know actually you take that battery lead away, we've got 10 millimeters of clearance. That's enough for me. So we're happy with the position. If we wanted to move them, we could move them now with the move copy, and then we can use it as we do, move it as we do any other part, but I'm going to leave that there for now. Although my computer's doing well, it gets a bit chuggy occasionally, so just to help things along, we're going to remove as much of this mesh as we can that we don't need, and that'll just help us along. So anything in front of this line on the engine and anything behind the bulkhead, I'm going to remove. So for that, I'm just going to use offset planes from the origin offsets and position them about where I want them. And then we can do plane cuts here on the mesh. We select the mesh, select the plane, and there you go. You can see we're already removing some data, and you know what? We'll just slice it like that, so that's gone as well. So I continue and do that on pretty much all of the origin planes on both sides of the model. Be aware though, you can't bring the deleted parts of the mesh back without importing the whole of the mesh again. And there we have it. We've got a lot less data to worry about. So now I've got only the bits of the mesh on the screen that I want. I'm going to do some tidying up and some reduction, because the engine bay has got 620,000 facets and the carbs nearly 2 million. So we're going to do just a bit of tidying up here. First off, we're going to do a remesh. The remesh function allows Fusion to do its version of the mesh, and that often means it works a little bit better rather than looking at the mesh that comes straight from the 3D scanner. I recommend using adaptive to keep the details nice and sharp. So that's the remesh, and you can see that the size of the facets is now far more uniform, and now we're back down to under 1 million, and we're going to do the same for the engine bay. Now that has sped things up quite well. If you need to, there is also the reduce option. So let's try that. We're going to just reduce the carbs slightly. I like the option here where you go for tolerance, and you can select a tolerance that you want the maximum deviation of the new mesh, which is simpler, to be from the old mesh, which is of course more detailed but more complicated. So if we're going to say 0.1 of a mil, 0.096, so I'm happy for it to be a coarser model as long as it doesn't deviate from the original mesh by more than 0.1 of a mil. And you can see we're down to just over 250,000. You could reduce it more if you wish to, but I'm happy with this. So before we get stuck in with the actual modelling, first thing I'm going to do is a bit of admin, which I should have done to start with, is change the name of the meshes. Just help keep it tidy. The next thing we need to do is to turn off capturing design history. Now don't ask me why we've got to do this, but certain tools only work when you've got this turned off. That's just the way it is. So now we've turned off capturing design history, we can do what we need to do, which is create planes at the main interaction points. So first thing we'll do is on the carbs. So what we want to capture is this face here. So we're going to create a plane based on these flat faces here on the edge of the couplers. So we go to construct, plane at 3 points, and we can now pick up points on the mesh itself. So we select 3 points that are reasonably far apart and have separation in the 2 dimensions that we want on the mesh. And there you go. That is pretty good. So this 3-point method of finding a plane isn't perfect, but it is plenty accurate enough to the type of work I'm doing here. But if you guys want an even better method of finding a plane, then I suggest you check out Zeiss Inspect or GOM Inspect. There's a segment in this video on it, and that will use some heavy statistics to find the true plane within your mesh. So that's one done. Now we're going to turn off the carbs and go to the engine bay, and we're going to do pretty much the same thing on the face of the head. We'll start a sectional tool, and we'll just cut all of that data away for now that we don't need, just so we can see the engine. There we go. And we'll turn that plane off, but before we do that, we shall call it carb plane and turn it off so it's not in our way anymore. And then we'll do exactly the same thing. Construct, plane through 3 points, and we'll again pick up 3 points that are separated on the plane that we need, and we'll have a look at it from a few angles. Again, that's looking pretty good. So that will be perfectly accurate enough for our needs. We'll rename that plane that we've just created, head plane. Turn off that sectional analysis, turn on the other carb plane and turn on the mesh, and you can see now we're in a good position. We've got the 2 meshes and we've got the 2 planes that we can start doing some proper construction from. So now we've done that, we can actually turn the capture design history back on. So now we can use the timeline as we would do normally in Fusion. So we can go backwards and forwards and correct mistakes or make changes as we need to. So let's just focus on the carbs for now. So we turn off the engine bay, turn off the head plane, and here we are. So what we need to do now is we need to have a good idea of where these are, all these circles, where they're centered on this plane. And as you can see at the moment, especially at the edges there, the circles are a bit messy. But if we look here, what we've got is some pretty good circular data about in this kind of area. So we're going to use a lovely tool called Mesh Section Sketch. So the first thing we need is a plane that goes through the area we want to section. So again, offset plane, we'll grab our plane we've just created and drag it to about where we want. And that looks pretty good. And then what we'll do is we will create a mesh section sketch on the new plane. So what this does is it creates a sketch on this plane everywhere the mesh slices through it. So if we turn off the mesh now, you'll see it a bit clearer. So that's everywhere on that plane that the mesh slices through. And you can see we've got some pretty good looking circles there, which is exactly what we want. So now we can go to the sketch and we can click, which is this sketch. So that's mesh section carbs. And we can go in and edit that. And then we can use the other great tool that we've got at our disposal, which is fit curves to mesh section. So this then gets the computer involved and says, right, statistically, please fit me sketches and curves to the data I have on here. So we're going to go to this, which is the circle. So if we then click this sketch, it will try and fit a circle to that data that I've just clicked. With an ideal curve, we are 0.2 of a millimeter away from the sketch that has been created. So that's pretty good. We can actually do the same with all of them. So there you have it. We've now got, from the mesh, we've got some proper hard information. So what I like to do now is just do a little bit of sanity checking. So we can go in and we can put some measurements on this. So now I've put measurements on everything, we can pretty much decipher that we're on 74mm hole centers between the carbs, and we've got a pretty good center line with minimal deviation. We might move that one across, or to be sure about it, there really is no substitute for actually just measuring the thing itself. I mean, these aren't obviously the carbs, because the carbs are already on the car. These are just a random set of throttle bodies I've got just knocking about. In fact, these are off the Fiesta, if you remember that. Project Shipbox. Anyway, the point is that either from the 3D scan or from measuring the actual item, we can put together where we think those holes are on that plane. And quite honestly, 0.1, 0.2 variation of a millimeter makes no difference to me whatsoever. Neither does the detail off the center line. All we really need to know is where those holes are. So we're going to live with those circles as we have them on that plane. Now you might want to go a bit further, you might want to refine that, depends on what you're after. So if we turn the carbs back on, those sketches are halfway up the couplers, but where we actually want them is on this surface. So we're going to do the next stage. So if we go to solid modeling now and we create a sketch on that plane, then we can project the circles from that other sketch. We might need to turn some things off so we can see it. We can project the circles through. Again, be very careful, make sure you're only selecting the circles that we created from the mesh section sketch. We can finish the sketch just to make sure, and there you have it. Turn the mesh back on. You can turn that other plane off and that other sketch off. And there we have 4 circles that we don't have to use, but what they does give us are centers of each of those carbs within plus minus 0.1 of a mil. That is good enough for me. So it is up to you whether you choose to use the scan data directly, or you can modify it and put in 0.00 precise values that you've measured directly from the part. For this application, 0.1 of a millimeter won't make any difference, and it's up to you to decide where you spend your time and effort and where you feel the accuracy is required. We're going to pause that there, and we're going to go do the engine side and turn the carbs off and turn the engine bay back on, and we're going to turn our head plane back on. So you can see there's not much data here to model from, and that's because I didn't really scan this surface directly. I was scanning along the top of the engine bay. I never really made an effort to scan this because for my purposes I don't need to. If you do need to, then I would suggest you either scan the induction manifold that came off it, or you scan the head in more detail. But that is good enough for me because I have got a cheat, because I already have a drawing of the flange. So I can utilize that by creating a new sketch on that plane. So now we're sketching on the plane on the front of the engine. I can insert DXF, from my computer, and then we can manipulate that as we do any other drawing that's in the correct orientation. So what we're going to do now is move this whole drawing in above the scan. So I'm not doing anything fancy here, I'm just using the move copy commands to move the sketch so it looks like the studs, which are the only thing I really was interested in scanning on the head, are lined up with the holes on the drawing. A couple of tweaks and we're there. Just to make this placement live a little bit, what we'll do is we'll extrude the flanges. Let's pick 17mm. And there you go. That helps us visualize whether we've got the placement right. Certainly looking at the studs. And I'd say we do. So I've turned all the data back on again so we can see where we're at, which is we have a flange modelled on the head in the right position. We also have a drawing plane ready to go on the face of the carbs with the centre of each inlet track marked. So from here on in, this is just a normal 3D modelling challenge with lofts and extrudes and all the normal stuff you would do. So what I'm going to do now is skip fairly quickly through the 3D modelling, but if you would like a step-by-step, baby steps version of how to model this, then please go and check out this video, because this video takes you through every single step. In fact, there is a 40-minute section on how to model inlet manifolds. But right now, I'm going to whip through this. The main job here is to create the forerunners between the carbs and the inlet port. So to do that, we're going to stay in solid modelling and we're going to use the loft function. Now to get a nice smooth curve on the loft, you need a centre line for the loft to follow. So go into side elevation and I create a spline that gives me a nice smooth transition between the two planes. Next, we need two circles to connect. So we have a circle on the sketch for the flange and we also create circles of the correct size, concentric to the circles we created on the mesh section sketch for the carb. Then we just choose the loft function, the two circles we've created that we want to join, and the center line, and voila! Repeat that for each of the runners, rename, and do a combine so the flanges and the runners are all one, and we've got something. So it's took me a few minutes to model that up, and this is where 3D printing proves its worth, because I can print that in the cheapest 3D printing filament I have, and it's got all the information to know if I'm going to be on the right track. I've got 4 spots there I can hold the carbs up to, I've got a flange on the other side, I can slip onto the head and make sure everything's going to fit. So that's exactly what I'm going to do. Well, I did. So now we've got the core of the model and what we need to make sure it'll fit, we can do stuff that will make it look pretty and work properly. So first thing we need to do is put the bits on the end that go into the couplers. And to get these kind of dimensions, especially on this little groove that's just inside there, if you can see it, we're really better off using calipers and then doing a little bit of trial fit, because this needs to click in really nicely. So to do this, I'm just taking the dimensions I've measured directly off the part and creating a stubby little cylinder, making sure in the process that it's a new body and not joined to the existing runner that we're building it off, for reasons I'll show later. Then for the groove, I create a circle on a plane through the middle of the stubby cylinder and then do a revolve cut extrude to make the groove, and we've done it. So I'd recommend 3D printing that to make sure it's a perfect fit, and then once you're happy, we can then just take that body and copy it across to the other runners and combine it with the existing bodies, and we're done. There we have that. So that's the one interaction side done. And then on this side, we are going to put in some O-rings. Now I've used these O-rings, which came from a BMW Mini, and they are, well, they're standard OEM fitment. So if they're good enough to last for a car's lifetime from BMW, well, you know what? They'll do for me. So measured them up, and then again, you guessed it, we did some test prints to make sure we knew exactly what worked well. And then because we've got the timeline, we can go all the way back to the sketch where we brought in this, and we can just modify this sketch to give us those grooves. So we're going to put the O-ring grooves on the original sketch because that keeps the timeline tidier. And if we choose to export the sketch as a drawing, we've still got all of that information and we carry it with us. The only thing left to do now is to cut out the inside of the runners, and for that we're going to use the loft function again. So it's the same process. We get profiles at either end that will match the port in the head and also the diameter of the carb. We pick the same center line as we did before, and there you go. Make sure you're using the cut function, but it should default to automatically, and repeat 4 times and you're done. So there we have our finished model. That looks pretty good, but this video wasn't about that. It's how it fits with the meshes that we scan. So if we put them back in, then you can see here that it looks pretty good. Almost like it was made to fit. So that's it. We've got the 3D model. We know it fits because we've done some prototyping and we've offered it up and we know it fits. And we've also done some pre-work on some of the detail of how it fits either end. So we're fairly confident this is going to work first time out. So now we've just got to get it made. So we can either get it 3D printed, which is what I'm going to do or did do, or you could get it CNC machined or any other way you choose to manufacture it. But what I chose to do was 3D print it. So I'm going to show you a bit more of that process just to round out the video. So I printed these on my Bambolab X1C and it did a fine job. I also used Bambolab PA6 glass fiber because, well, it was the only one they had available on their website when I needed it. And to be fair, I wanted to try some of the others, the PA high temperature, but to be fair, this did a great job and is really nice and stiff and absolutely no complaints, printed like a dream. Getting them on the car, they fitted like a glove. It really was very nice. And after a quick driveway test, well, what's better than to test these things out in competition? So it was off to do an event. There were some issues with failing fuel pump. Thank you. Exploding coolant system, but none of that was related to the carbs, and hey, when it was going, it was flying. I think we'll call that a success. So I made this video to show how you can model things directly from 3D scans. And will it be exactly the same process if you're doing a different part, maybe an interior piece? No, it won't be exactly the same, but the same principles will apply. Am I a CAD professional? No, I am not, but I've got some good results from these methods. So if you're looking to start, if you're looking for a place to start your CAD journey from 3D scans, well, tell you what, I think you could do a lot worse than follow these tips. So I'll put all the files I used here, including the 3D scans, on my website so you can follow along or even print out the same thing if you wish to. And while you're at the website, yeah, you could buy some merch. You'll be the first. Maybe that tells me that I need some better merch. Also, I've got a Facebook page now, which I try to update more often than this channel. Emphasis on the word try. If you're still watching now, please give yourselves a big thumbs up by pressing the thumbs up button on this video. Subscribe if this is useful to you so you don't miss any videos. If you really want to help the channel, then check out the Patreon page. I can't promise any extra content, but I can promise you'll be helping me out enormously. Right then, I've droned on long enough. Until next time, stay hydrated.